Hi everyone. Thanks to Miko and Haida for inviting me here today to speak to you. I'm going to be talking about how we accelerate automation in logistics and how simulation allows us to do that. Are we working? Also use the space button. Right, so who am I? I am George Walsh. I work for DHL in the digital manufacturing team. A little bit about my background. I have sort of 8-ish years robotics R&D experience and system integration. Funnily enough, I actually started my sort of career journey after university here, right on this floor, doing an MTC graduate scheme, so got a lot of experience with industrial robots, how to actually design applications, and 4 years here, I took on the challenge of going into the real world and seeing how to actually make these things happen and make them happen reliably. And it's always a little bit more fun than having these little demos, but comes with its challenges. My main engineering focus is robotic solution design, making flexible automation systems, making them scalable, and really developing those business cases for our customers. So as I said, I work for this digital manufacturing team within DHL. It was born out of this startup lab program that DHL ran. So it was these incubation programs. So people could propose their ideas. 4 bright individuals proposed an idea for, okay, DHL needs a lot more automation. As Steve mentioned, the UK and generally a lot of the countries where DHL may be is really, automation just isn't there. There's a lot of manual operations. So they had a bright idea to come up with, okay, we're going to do automation in-house. Great. They're a bunch of business people and they didn't really sort of know what to do. They started with collaborative robot applications, pick and place things, but they decided actually we can't do this ourselves, so we're going to develop an engineering team. So this was sort of 2018. I was employee 6, and we're now up to a team of 16 engineers, and we have a business development function. We're kind of growing steadily as the business needs us, but it's a good pace, and there's some good projects I'm going to show you that we've done over the last few years. But our skill set is we got mechanical and fabrication, so we have just moved into a new facility, this year, where we have a fully kitted workshop, so we have lathes, milling machines, a 3D print farm of sort of 20 odd printers, so we leverage 3D printing quite a lot on our applications. Electronics and controls team, so PLC programmers, electricians, electrical designers, and also microelectronics is something we delve in. Simulation as well, obviously, and software, web analytics, so all the data side of things. So we've got a team of 3 data and software engineers who make everything talk and get us all the data back. So what I'm going to do first is we can kind of go an overview. I'm going to give you a good overview of DHL. A lot of people might know actually how DHL as a business works. Might think it just delivers parcels, but I can show you that it does much more than that. Then introduce the digital manufacturing team and how we fit into it and fit into the wider, I suppose, strategy of DHL. Explain how we use simulation and some case studies, and then hopefully we'll have time for questions at the end, but if not, we can always catch each other after. So, DHL Group, who are we? We're a pretty big company, sort of 500,000 employees globally, 5 different divisions. So we have the post and package, most people know about that. We have Express, again, that's planes, packages, real fast moving goods. The freight, so I think if we talk about freight, I think DHL has sort of the 5th biggest airline in the world. So it's quite impressive. That was during COVID. There was quite a lot of noise around that DHL had its own airline with no people. So people were really piggyback on that. So that actual business unit really sort of went quite big over COVID. E-commerce, so the e-commerce sort of boom is happening. There's configurability of products, all of these quick moving items, and supply chain is where we sit. So that's all your packaging, all your configurable products, anything orders, it's quite a vast variety of things, but even from manufacturing, supply chain to life sciences, so it's quite a vast array of products we deal with. So, DHL supply chain, we are all over the globe. So, really everywhere in America, UK, Ireland, Europe, various places, sort of Asia, sort of Australia. So yeah, it's pretty much all over the globe. I think if we look at the supply chain solutions, we are twice as big as the leading competitor or the next competitor. So yeah, scale is really important to the business. In supply chain, we have nearly 200,000 full-time associates and 1,500 warehouses and locations, and these things are, some of these warehouses are no small feat. But if we focus on the UK, because that's where most of our business tends to, we do have some projects in Europe we've done with, and some starting out in America, but UK has been our primary focus. We have 40,000 employees, so again, it's sort of still quite big, but relative to the business, it's quite small. 400 operations, loads of warehouse space, and lots of customers. All these different sections. So as I said, we do manufacturing, logistics, retail, and consumer. So that's the big one our team seems to delve in quite a lot. Life sciences, supply chain services, and the whole transport network. So this is what's the big problem or big challenge that DHL are trying to solve for this? They want to say it's next generation logistics, the value offering to their customers. Problem statement is there's this ever increasing customer expectations, the tightening labour markets. So this is a big one that I think that everyone faces. The pace of technology is accelerating, especially this year with the whole AI boom. It's really hard to keep up. Actually, it's constantly, every week there seems to be something else to look at, especially in the logistics space. You see constant different technologies for container unloading, for understanding the metrics around a business. It's constantly moving. And disruption of climate events, so being able to actually make all our operations green is a really big push at DHL, and there's a few areas actually our team has got involved in to push that. So how does the future state want to look on this? We want to be responsive and flexible. We want to really supercharge the human, so that can be that might sound like you want to get exoskeletons on people, but it's really making people more productive. It's for every one person you have, you want to make them as productive as they can be, because those people are in short supply. So it's really making their job as efficient as it can be for the operation. Fast-moving goods, fast-moving projects. All these the world is changing, and the products we deal with are changing. So we need to be fast. We need to be really fast and scalable with our deployments. I'll kind of briefly talk on this later, but if we kind of go for how a supply chain works, there can be short contracts, there can be 2-year contracts, 5-year contracts. Trying to get any automation in that period for a payback where you might not win the next contract is really, really challenging. So, DHL really needs to be, and especially our team, fast with our deployments. And we really look at sustainability as a big metric in the business. So, not so much from some of the stuff we deliver, but most of our warehouses now are really going for this sort of green approach. So the warehouse I currently work out of, we have an office there just over the road there with Crosspoint Business Park. The whole warehouse is run on solar, and also what our team has developed is actually battery storage containers. So solar will store the energy, also the energy from the lower meterage costs, and then that runs the facility. So it's it's the first one in the UK. I think Europe to actually get this kind of like nearly net zero approach where actually there's enough solar to run the operation. Well, during a good day, but. So, looking at DHL as a whole and all the different technologies we're trying to look at for this next gen logistics approach, assisted picking robots is massive in the business. This is really taken off. So you got your sort of Locust, 6 Rivers, all the different companies kind of all offer a similar solution, but it's really trying to see who can scale the best. Goods to person robots, again, same sort of concept. It's really all about trying to make operations as efficient as possible. packing technology, so these can be automatic pallet wrappers, indoor transport units, so try to reduce the amount of people that need to go on forklifts and actually, use automatic forklifts. Unloading technology, so in the States there's a Boston Dynamics stretch pilot happening. In the UK we have one happening with a company called Robot, so it's all about this container unloading. There's a lot of other companies doing the same thing, so it's a real hot topic at the moment. AI and data analytics, massive. It's being able to see what's happening in your operation at any one time. This is traditionally, if you kind of look in, especially in our business, it happens, but it's quite delayed. We want to know what's happening now. You can get maybe weekly reports, daily reports, but actually you want to see if something's happening, if your operation's been unproductive at the last hour rather than over a day, over a week. Smart operations, wearable devices, trying to make process automation, intelligent process automation. Sortation technology, again, that's a lot of what we deal with. Supporting robots and tracking and monitoring. So these are all different areas of the business sees this next gen logistics for making us as competitive as possible in the market. And all leading to this ideal approach, which everything is large scale automation, ASRS approach, where products come in, goods go out, and all kind of happens automatically. Baby steps though to get there. So, digital manufacturing. Why do we exist, or what do we do? So, part of the problem with trying to get any automation in these businesses, especially in DHL, is these short contracts, and also the sort of trying to actually get the payback and try to put them in at the right time. So to do that, we have to take control of the supply chain of our products and how we sort of develop and choose what we put in our systems. So we evaluate and source everything. So we try to get the best price on everything. If we can't get it for a good price, we try and make it ourselves. So that's why we leverage 3D printing a lot. We design and produce as much as we can. Obviously, we don't want to reinvent the wheel on a lot of things. We need to buy certain components, sorters, bearings, all these things, all the robots, all the standard things we will, but it's all the parts around that we make. So our whole value offering is to make these production lines and the operations as efficient as possible, but a lot of these are very manual lines, so we have to make them so when we implement our solutions, it doesn't interrupt the operation. A lot of the time we're putting a piece of automation kit in an already existing manual operation, and it all has to fit around seamlessly, and downtime is pretty much off the cards. So the challenges can be quite big. And what we get from our systems is we need to see the data of everything. We need to see how many parts are going through an hour, if the system's running, if it's not, if a motor's failed, if a motor is overheating, everything. We want to get everything on our systems. We'll have our own dashboard that shows the engineering dashboard, and production will have their dashboard which shows all their rates, all the stuff they need to see, so we can tailor that to the customer. So the next part of it is palletizing. If you've been to any warehouse, if anyone's been to the warehouses, but containers come in full of product and they need to go into racking somewhere or go onto pallets. And this happens in every warehouse across the country, across the world. Sometimes things come in on pallets. A lot of the time you'll get a container from China, fully packed. The most expensive thing in a container is air, so they really make it as packed as possible. And traditional approaches flood people into the container, off onto a conveyor, a few people around on the line actually palletizing it. One, it's just not very efficient use of people, and two, it's actually there's quite a lot of injuries, especially in warehouses. That's one of the highest injury risks in warehouses, so palletizing just makes sense. So I think we've employed sort of, over the last few years, sort of like 15 of these applications around the place, and it's sort of, we're only on the start of that. There's still a lot more to come, but it's just something that's really needed in the business. But one of the challenges with palletizing is the varied SKU or the varied product dimensions. So, on a standard production line, you might have a palletizer at the end, and you have one product, and you got to, that's fine. Our main problem here is that we have to have operators changing the products all the time. So it's really, trying to find the array of products that actually work with our palletizers. That can become quite a challenge. So we are actually in the process of developing our own one of these with a lot more features. These ones are off the shelf, but yeah, it's become a need to actually make our own one that has all the features and all the kind of operator interfaces that they need. And the last thing that we kind of we're big on are these dashboards. It's because we have the full control of the ecosystem. We're not relying too much on third-party, equipment. We obviously try to make as much as we can. We can control exactly what we see on these dashboards. We can, from the PLC, we can throw it to the cloud. We can. This is an example where we're checking the picks and places of different robots. We're seeing the uptime. We're actually seeing when various things happen, like whether a vacuum filter. We can see when things like vacuum filters jam because some of these environments are quite dirty. We can see how many trays are produced. We can actually, on this instance, do a charge per pick, so you can get quite a lot of stuff for the customer. And we can see when issues happen even before they realise they happen. So there is some level of predictive maintenance that goes on in the background. So with all these things, I'm kind of now going to go on to how simulation actually ties a lot of this together. So these are all the applications and some of the applications we've made, but actually at the heart of it is visual components and simulation tool. So this seems to be the sort of the linchpin of a lot of our projects. Well, it's not the kind of it is just a piece of the puzzle, but it's extremely useful. If we kind of go from just the initial customer communication, so Steve touched a lot on this. It's great. That quick and dirty simulation you can put together. It doesn't even have to be moving, but sometimes it is. And what we do is bring them in. I've made a whole VR world of I think there's like 5 or 6 different projects that we've actually done in one world. Looks like a warehouse. Customers come in and see that, and they get that really blows them away. That they can actually go down to the production line and they feel like they're there. They can see their kind of this, their future, what the future state of their system could look like in their operation. It's all 2D CAD just does not have the same impact. Proposal generation, like as Steve knocked on, absolutely fantastic. Just being able to, that quick and dirty thing, but even a little bit more detail with metrics, statistics, showing how it fit into their existing operation. So because we only serve internal DHL, we have access to all the sites, so we can just go to wherever we see and actually look for these problems ourselves. So we can actually understand the process by looking at it and actually be able to spend time there, and that's how we can really help out with the solution that you develop the thing that's actually best for the customer. Mechanical design verification, it's just really good for for doing a robot application, whether the robot can reach various places, whether we've actually designed say a palletizer, we've actually put the pedestal the right height, whether or not if we're designing different cobot applications, are there going to be any pinch points? We try to really look at all that before we design it, because we can do this really quick, and it's nobody likes the mistake of making their beautiful creation and realizing actually there's a lot of problems with it. So it's really getting all that validation before we make project planning. So once we kind of have that initial concept, or even we know what we're delivering, being able to plan it and go, okay, here's my BOM, I can get the BOM from that. Okay, let's break this BOM into production time and actually figure out how long it's going to take in the project plan. And yeah, it just makes that whole process a lot better. And I've been a user since 4.0, so the addition of process modeling was like, it was like they created something. It was needed, but it really changed the game in terms of being able to actually develop processes properly. There was a lot of hacking around behind the scenes, but this has been actually developing a process and modeling existing processes and actually trying to fit our solutions around it and show the customer actually this isn't just something out of the sort of thin air. This is actually, we've looked at the solution, we've taken the data, and we've worked a new process into your existing process. And we do some PLC software development on it. Not full virtual commissioning, but we use Beckhoff for pretty much everything. And if I need to, or one of our engineers needs to make a piece of logic for, say, a conveyor sorting system, we can do that, develop that little unit block and test it on the real system. So it's really just breaking down some of these problems when the main system might be available or it's not made yet. So it's just trying to streamline packages of work. So now to get onto some of the more interesting things that we do with visual components. This is an operation out in America, and this sort of stuff happens all the time in DHL. Reconfigure packed goods. So 24 cans come in and they actually need to put it in packs of 4, and they do that all day, every day. There's a lot of inefficiency in these operations, but you know, they're not bad. They kind of got to put people where they go to, because trying to invest in a lot of these is difficult. Again, as I talked about, these things can only run for 2 years, so it's easier just to plan people to do various things. But it kind of turned out that actually they wanted to see what we could do with this. So at the moment, standard cycle time for this is sort of 20, 24, 25 cases an hour per operator. It's only 24 cases an hour per operator. What we do then is, okay, so taken the video, I've taken the footage, and I've actually modeled the exact process with the exact timings in visual components. We do actually have a whole, so one of the other things when I'm doing simulation and developing processes, we have a whole database of different timings. So this can be down to how long it takes for someone to pack a Mars bar, or how long it takes for someone to stack a shelf. All these, we have a whole database of this. So I take a lot of that from this and actually put it in there to get the real timings. In this instance, I've taken it off the video, but the process is modeled as well as I can. With a benchmark, that means what we can do is actually, with the model process, we know we're true to life enough on this and have the timings of that. Let's start adding some automation, actually seeing what we could potentially do. So by adding a packing robot and a repacker, because the tray needs to go back, so the same tray they need to go back in the same tray. Adding a few bits of automation again. There's nothing too pretty about this. It's just really to show the customer this is what you could have. But palletizer around the end as well. But you can see that per operator now the productivity is nearly doubled. We're at 45 cases an hour and a cycle time improvement of 64%. So it's this didn't go any further, but it was really to show the customer the power of sort of what you can do. And it's kind of it's all well and going with the Excel files and showing, okay, you could do this sort of hypothetically, but actually showing them it's so powerful. And this method has been used across the board, and we've used it on many different projects. But I think this is quite a good example I like using. So there's process improvement through simulation. Now what happens if we actually go to do an actual project? We had to use our simulation friend to develop a new process, and actually, okay, how can we show you something in the same, we can keep the project the same timelines, actually develop a whole new operation. So what we did was model this process, tried to figure out, okay, what's the best way to configure it in the space, how can we automatically put these leaflets in, what's the best way to put the USB cables in, what sort of cycle times can we get, how can we, what productivity per operator can we get, and what parts of the system can we automate, and what don't we need to automate. Placing on the conveyor, the boxes came in a lot of packaging, so that is it's much easier for people to do that, much more productive. All of this stuff where it's standard approaches, yeah, absolutely automate that. Anything to do with palletizing, automate that. The USB cables, they came in not very nice packaging as well, so what we thought was actually we'll put them in like magazines, so we'll make them magazines that they package from, put them in, and the robot still places them much more efficient because you can split out the operator's time. And from this, we actually we grouped 12 boxes together, so we actually went in groups of 12. It put all the leaflets in automatically, USB cables, and then palletized 12 at the end. Productivity increased 300% because each operator now, so it only runs with 2 operators, well 3 sometimes, sort of 2.5. It's 250 pre-kits an hour, and the payback period is sort of nearly just less than 2 years. This pays back in I think 6 months' time, and they still have like 2.5 years left in the contract. So this was one time it actually really made sense to automate and continue to automate. So here's the real system. So the timelines for this, I should say, 6 months. So that was from when we got it, the simulation sort of that project concept stage, that was where the real acceleration came of the idea of what to do, because using visual components you can just constantly iterate, and we always kept the customer in the loop. Usually to sign up for these projects can take quite a long time, you kind of go through different milestones, but once they saw what they were kind of going to get, they wanted this as quick as possible, so we kind of got the green light really quickly and delivered it out in the Netherlands. Since 2022, over 500,000 kits have been assembled through this line, and 2 months ago we put a new edition of a mirror robot. So one of the real sticking points of the system was this bottleneck of once the 2 pallets either side got full, there was no real way of alerting anyone. The 2 operators were busy packing, and then one of them had to go bring the pallet or try alert someone. So that all took a bit of time. So actually this seamless process now of having a mobile robot with 3 of these trolleys around, they have to bring them sort of 500 meters down the warehouse, but this constant process means that it just runs uninterrupted now. They have to fill leaflets and fill USB cables, but generally in the process it's pretty uninterrupted. And this has actually proved to be a 10% productivity increase, so the payback has got a little bit better. So yeah, that's one example of how we've actually used simulation, accelerated the project, delivered the project, and are still making improvements on the project. And the final case that I'm going to show you is, okay, so I showed you modular conveyors and why we make conveyors. We then took on the challenge of, okay, we can make conveyors, we can make 1 conveyor, 2 conveyors. How about a network of conveyors? And this is something none of us had ever done before, but us being digital manufacturing and quite a lot of enthusiastic engineers who decided to take this challenge on. So yeah, 15 meters of conveyor is probably the max we produced before. Spec for 365 meters. The timeline for this was, project started in August and delivered in December. So it was quite a challenge for a group at that time, 10 engineers. So throughput of the system, 2,600 boxes an hour. Operators are on these pick-to-light tables. They get orders in. They got to pick their items, put them in boxes, put them down chutes to go on the main conveyor. Boxes come around here, go through a scan tunnel. They can either go out where they might need some extra accessories. So you order something and it needs, you've ticked the additional boxes. We love that. Or it goes to the outbound lanes through different couriers, palletized out the door. And there's a whole cardboard waste lane as well for dealing with cardboard. The amount of cardboard waste is one of those things people really underestimate, but it is one of the big things. Everything comes in a box, and those boxes need to go somewhere. So, high-speed sortation line. To really, we didn't have much on this. Project started 18th of August, and we had to deliver in 11 weeks. But obviously, I was going to straight away get on visual components and see, okay, can we actually hit this? Are we, before we really think, sort of start building it, let's actually see, can we hit rate? So we sort of spec'd a lot of the components, picked these flow sort units, model them up in simulation, model the whole line up, and just to see, okay, is our theory about how we're going to sort this right? Can we get the throughput? We did ramp this up quite a lot and actually see, okay, when do we get sticking points? So things like when it injects boxes, we really had to think about that. When to do it, how big the gaps want to be, because you need a certain gap if you're going through a scan tunnel. If you get 2 boxes too close, they don't know if it's 2 boxes. So there's a load of different issues. So using visual components, and this was sort of done by the end of August, sort of really, really quickly, to see, okay, how are we going to build this? What are we going to do? What components are we going to pick? And once we could understand that really quickly, okay, well, it was great. We just built up a bill of materials, kind of spec the conveyors a bit more than what we're used for our 10-meter ones. But the process of using simulation to make those design decisions before we built a whole 365-meter conveyor network is really, really valuable. And here's a nice little stop motion of us building it. So I think this is actually November, so we really built a lot of it in like sort of less than 3 months. And here's a little day in the life of an order. So yeah, I think this was during commissioning. This video was taken. Some stuck their phone on the on a box. But yeah, you can just see the scale of this was something we'd never tackled before. But you know, we did it. It's working. It's, I think as of sort of last week, it's done over 2 million orders. So since sort of January, so it works. And yeah, it's the linchpin to the operation. So I guess if you kind of look at the projects we've done before, there've been additional parts of the operation. We've always given them a get out of jail if the system stops. They always have a manual intervention. This is, you know, this is the linchpin. So this has to work. So that's the kind of the difference of how we've, as a team, definitely matured. And there's more projects like this on the way. And yeah, hopefully everyone got a little insight into how the world of DHL and digital manufacturing works. Cheers, thank you.